What we'll be doing is a little bit more work with power functions and the regression tool on a calculator. And just setting it up is a power function is anything where x is part of the base to a power. I guess that makes perfect sense. So as we look at a few of these problems, I just want to make sure that it is a power function based off of just like what we know. Just what we want to make sure is, well, I guess anything can be written in this form with x as part of the base, but we want to keep it where it's kind of special, I guess would be the best way I could say this. So as I look at this first one, x is part of the base, 3 is the power, so this is just determined means yes or no. And what I would say is that the a value is 5, a being the coefficient, and then the b value from this problem is the power, 3. Now on this next one, I think what kind of ruins this is this minus 4 on the outside. So I'm going to commit to this one saying no. But on the next one, we could rewrite this a couple of different ways. Like I can move, instead of dividing by 4, multiply by 1/4, and rewrite the cube root as to the 1/3 power. So as far as committing to an answer, I'll say yes with the a value of 1/4 and the b value of 1/3. So care more about the ones that are yes. And with the next one, I don't know if you're thinking much about this, but you could rewrite this with a negative power. So I'm going to say yes on this one as well, with a being the 10 and the b equal to -2. So I'm concentrating a little bit more on the yes ones. And what we want to do is play around with this, and then again we'll get to a calculator, is discuss what has to be true of a y-intercept. And it's been, well, hopefully it hasn't been that long and you haven't forgotten that the y-intercept is always when x equals 0. So the reason why they have this statement that the base must be greater than 0 is, or I shouldn't say base, the b value is greater than 0, is 0 to positive numbers is always equal to 0. So if I ask you for the y-intercept, it's equal to a times 0 to the positive number, and a times 0 will give me 0. And if I go back to some of these problems, so the y-intercept is 0. If I ask you to graph y equals 5x cubed, its y-intercept is 0. This one, the y-intercept is 0. Now this one does not have a y-intercept because it's a negative exponent. Which is exactly what I'm going to talk about with this one, is 0 to a negative power is undefined. I'm just going to write UNDEF, undefined. So therefore there is no y-intercept. And maybe I could just go to a calculator and just show you, if you had in y equals, I'll just do x to a fraction, like 1/2 power, versus x to the -2nd power. So the blue one will have a y-intercept at 0, and the red one will not have a y-intercept. And that's exactly what happened. So feel free to play around with different numbers, see if that always happens. What if you had like a negative fraction? So like -1/2. Still no y-intercept in there. So that is correct. So here's another one where they want you to practice using a graphing calculator. I hope you remember this first one from our unit with quadratics, is that it's the U shape at the origin. Now we haven't talked about x cubed yet, at least I don't remember talking about it. Now think about it, is you still get very large numbers very quickly to the right. And I'm less concerned about how quickly it goes up. Being cubed goes up faster than being squared. But think about now when you plug in negative numbers, like a -2 times -2 times -2, you'll get a -8. So that's why this function goes back into the third quadrant. Play around with the next one. Okay, so it actually grows faster than the x cubed because it's x to the fourth. But then think about if you did -2. Well, if you have 4 negatives, I'll just write it like this: negative times negative times negative times negative. Well, every 2 negatives is a positive, and a positive times a positive, we're back to being positive. Now, it does grow faster than this quadratic over here, but it has very similar behavior. I can do the same thing with 5 negatives. 2 negatives make a positive, 2 negatives make a positive, but you have 1 more negative. So again, it does increase very fast, and but it's the first and third quadrant. That's what we want you to get out of that. So as we look at the next one, there's a few things that you just need to recognize. Is you see how when you look at this, they both end in the same direction. So think about, like, well, I could just kind of jump to the final answer. But every graph that we had in exercise 3, they were all either going up, I'll just draw it like this, or maybe a red curve when they were like this. So definitely not the red curve, because the red curve ended in opposite directions. And the thought process was, if you had the red curve, we had an odd power. So as I look at my options, we don't want the odd power where they have the opposites. So it's not to the 7th, that's an odd number, and it's not to the 9th, that's an odd number. But when you look at the remaining 2, think about what we did in a previous lesson to take that graph and flip it over the x-axis. It's an x-axis reflection, and what we did to make an x-axis reflection is we had a negative in front. So I don't know how exactly you'd want to write it down, but in order to have an x-axis reflection, or some of you might call it a flip, is to negate a negative in front. So that would take that blue curve and flip it upside down with an even power. So that's why option 2 is the correct answer. So as I look at the next one, we'll need to use a calculator, and we'll be going through a process to come up with the linear model that fits our data as perfectly as possible. So here's just a quick, scenario where we have germinating corn plants. They grow as a height in relationship to the amount of days that they've been in the soil. Or I guess when they first break the soil, so when they first pop up. So here's the data. So after 2 days, it was 6.3 centimeters high. After 42 days, it was 27.6. And so what we're going to do is just type this into our calculator. You may remember this from a previous lesson. So in my calculator, first of all, I want to clear out, just in case I need those again. Go to Stat, and you're going to edit. And I have things in here still. But I'm just going to type in, remember your first column is all of your x values. And feel free to bring questions to class if you don't remember how to access this stuff. Let me remind you, I guess I didn't even say it. I hit the Stat key, and then you hit Enter on Edit. And then you can pull up your list and change your numbers. So now what I'm going to do, after I have all that data put in there, I have to quit out of this, so second mode, and then go back to your Stat key. But instead of editing the list, you have to hit the arrow over to calculate. And you may remember from a previous lesson that we did linear regression. But this time, I think what we want is a power regression, because we don't know what kind of exponent we have. So I think it's this button. List 1, list 2. Let me clear this out. I'm not sure what that was. And what I can do is hit alpha trace on my store, and what it does is it just saves my equation into y1. And if I hit calculate, it gives me a value like this. So what does this mean is they came up with their own regression, or their own equation where 4.34 is the A value and 0.489 is the B value. And so what we would do is write the equation like this. Y equals, to the nearest hundredth though, is 4.34 x to the 0.49 power. Hopefully I remember that correctly. 4.34 x to the 0.49 power. And so what does that tell me is that gives me an accurate picture if I were to look at my graph on the graphing calculator. So because I stored it into y equals, I can actually look at the graph and see about what the equation looks like. And I could even hit second table and see, you know, if you remember we did when x was at day 2 was about 6.3, well, we got 6.09, that's pretty close. And at day 5, we got 9.54, pretty close. And what I can do is actually just use this table and go to the 30th day and see that I get 22.94. And remember, that's called interpolation because that's inside of the domain, that because we call things interpolation when it fits inside the data set. So because it's between 2 and 42, that's an interpolation. Now remember, since I used my table, we got an answer of, I already forgot what it was, 22.94 centimeters. But if you use this equation, let me quit out of here, and it was 4.34 times 30 to the 0.49 power. And if you did that, you get a slightly different answer, 22.98. So I'll accept both answers. One's a little bit better than the other. Yeah. So I like this answer better because there's no rounding, but this is pretty good as well. And if you did the nearest tenth, this one would be 22.9, this one would be 23.0. So there's a couple of correct answers. So as I go on to the next one, extrapolation. You see how 60 is larger than 42? So that's what we call extrapolation, when you go beyond. So if I were using my equation, you would type in 60 instead of 30. So 32.3 if I round. So let me write EQ for the equation. I already forgot what it was. 32.3. But if I went to the table and scrolled down, 32.2. So the whole thought process is that this is very, very close to the form of y equals a times the square root of x. And think about like what our answer was, because a square root of x is the same thing as ax to the 1/2 power. That is the same thing. So I would say very close. And the whole thought process is that this plant will probably continue to grow, but at some point it might reach a maximum height that you can't get any taller. And just think about humans. Like after a certain time, you know, as you're first born, let's say you're born at this height, you grow really, really fast. You start to slow down. You might hit a growth spurt. But eventually you sort of, I guess, reach a peak. And that's sort of the same thing that's happening with a plant, you know, something like that. But anyway, you should be ready for your homework and be ready to need your calculator, so you might have to do a few problems in class.